Good day, everyone. So, in the previous lesson that we learned how to integrate polynomials, constants, exponentials, and logarithmic functions. So now we are going to move on to another group, which is the trigonometric functions. So we already know that derivatives is just simply the reverse of integration, or shall we say integration is anti-derivative. So I think last semester or we had midterm or prelim, we have the derivatives of trigonometric function. So we all know that sine x, the derivative of sine x is cos x is negative sine x, then derivative of tan x is secant squared x, derivative of cotangent x is negative cosecant squared x, and derivative for secant x is secant x tan x, derivative of cosecant x is negative cosecant x dot x. So to find the integral, we reverse this derivative. So kung nasa screen ninyo, these are the integral of the trigonometric function. So integral of sine x is negative cosine x plus c. Integral of cos x is sine x plus c. Integral of secant squared x is tan x plus c. Integral of negative cot x plus negative cosecant squared x is negative cot x plus c. Integral of sec x tan x is equals to sec x plus c, and integral of cosecant x cot x is equals to negative cosecant x plus c. So for example, we have this function of negative 5 sine x dx. So negative 5 sine x dx. So for the constant, we will not we will only integrate the trigonometric function. So remain negative 5. Then the integral of sine x, in our copy, integral of sine x is negative cosecant x. Simplify, negative times negative is positive. So integral of negative 5 sine x dx is 5 cos x. That is how you find the integral of trigonometric function. Another example is we have 3 secant x, secant squared x dx. So copy 3. Integral of secant squared x is tan x. Simplify, this is 3 tan x plus c. Same with this one. So always have the constant variable. Another example is we have this one. There is an application for the ratios of trigonometric function. We have 2 over sec x dx. So we will separate the constant and the trigonometric function. So we can have 2, 1 over sec x dx. And we already know that 1 over sec x in our ratio is cos. If we are going to go back with trigonometry, we have sine, cos, and also tan. Cos is secant, sine is cosecant, or the inverse or the reciprocal of sine is cosecant, reciprocal of cos is secant, reciprocal of tan is cotangent. So we can say that 1 over sec x can be written as 2 cos dx. And we can integrate 2 cos dx, that is equivalent to 2. Derivative of cos is sine x. Sine x plus c. So, dili kalimutan ang trigonometric ratio. Another example, we have the integral of 5 over cosecant x dx. So again, separate the constant and the trigonometric function, that is 5, 1 over cosecant x dx, and 1 over cosecant x, its reciprocal is sine. So we can rewrite this equation as 5 sine dx. Integrate, copy 5. Integral of sine is negative cos. Simplify, that's negative 5 cos plus cos x plus c. And that is how we integrate trigonometric functions. So last meeting, I also talked about there are some functions, either exponential, trigonometric, or logarithmic, that cannot be uh, answered directly using power rule. So I'm going to introduce to you the second way of finding the integral of function, which is the substitution method or the U-substitution. Okay, for substitution method, again, there are integrals which cannot be easily solved by the basic rules or the power rule alone. Doesn't work directly. So we can use U-substitution or substitution method. This is the reverse or inverse of chain rule. So the concept behind the substitution, there are 4 steps in substitution method. First, we are going to identify the function. This is the first one. Or you think which is hard enough to integrate a function that we cannot integrate directly. Next, we are going to differentiate or find the derivative of that particular function. And after finding the derivative, we substitute u and du, and we integrate in terms of u. And we substitute back the expression for u. So we cannot relate this one, or we need to have examples para makarelate mo no, sa ako ang ipangyaw-yaw karon. So for example, we have this function 2x times the quantity of x squared plus 3 raised to 5 dx. So first step is we are going to identify asa man nga function dira ang lisod kaayo nato kwaon ang integral. So we can say that this function inside the parentheses can be substituted or will be substituted as our u. Or we can identify this function as our u. So our u is equals to x squared plus 3. After that one, we find the derivative of our u. Derivative of our u is 2x. Because derivative of x squared is 2x. Derivative of constant is 0. 2x dx. This is the basic rule for integral. We should have the dx after we derive the function. After that one, we will go back to our function, which is 2x x squared plus 3 raised to 5 dx. After this, divide both sides by 2x. So we can have the value of dx, which is equivalent to du over 2x. So again, we're going to identify first the function, our u, atong lisod tanawon, which is x squared plus 3 raised to 5. After finding our u, we're going to find the derivative of u. So we say du is equals to 2x dx. Divide both sides by 2x, so we can have the value of our dx, which is equals to du over 2x. So let's go back to our function. So we can change our function into the integral of 2x u raised to 5. Since our u is x squared plus 3, so we substitute x squared plus 3 to u, or we change x squared plus 3 to u. And our variable of integration will be du, will be dx. Again, after changing this function into u, we have 2x u raised to 5 ayon dx. And we solved earlier the value of our dx. The value of our dx is du over 2x. So we substitute integral of 2x u raised to 5. Our dx is du over 2x. Cancel. We can cancel out 2x. So the remaining variable will be u5 du. So power rule for u5, u raised to 5. So this is plus 1. We have plus 1. And we also have 5 plus 1. This is power rule. So we have u6 over 6 plus c. u6 plus 6. u6 over 6 plus c. So is this the final answer? Hindi pa. So we have the value of our u, which is x squared plus 3. We substitute x squared plus 3. So we have x squared plus 3 raised to 6 divided by 6 plus 3. And this is how we use U-substitution to find the integral of a function. So I know you have a lot of questions for this example that we have. Okay. And I zoom it in. Okay. So let's have another example. Example number 2. We have the integral of 5x raised to 4 multiplied by the quantity of x raised to 5 plus 2 raised to 7 dx. First, we are going to find our u. Our u is equals to x raised to 5 plus 2. So derivative of our u, that will be 5x raised to 4 dx. Find dx. Divide both sides by 5x raised to 4. So we have the value of dx, which is equals to du over 5x raised to 4. And we will go back to our function. So we have 5x raised to 4, since x raised to 5 plus 2 is our u. So we write u raised to 7 dx. Next, we have the value of our dx. We have the value of our dx. So we substitute dx to this dx that we have. So our new equation will be the integral of 5x raised to 4 u raised to 7 du over 5x raised to 4. Simplify, cancel. So the remaining variable is u7 du. Using power rule, plus 1, also 7 plus 1. So we can write u raised to 8 over 8 plus c. And since we have the value of our u, which is 5x, x raised to 5 plus 2, we will substitute it with our u. So that is x raised to 5 plus 2 to the power of 8 all over 8 plus c. And this is how we find the integral of this function using U-substitution. Okay, let's have another example. Example with involving exponential equations. So we have the integral of e raised to 2x dx. E raised to 2x dx. So which could be our possible value for u? Can we use e as our u or 2x as our u? So we don't have any problem with e. So our problem is the exponent, which is 2x. So our u is equals to 2x. And find the derivative of our u, which is du equals 2 dx. Find dx. Dx is equals to du over 2. Then we substitute u to our function. Substitute u to our function. So we have e, the integral of e raised to u dx. We have the value of our dx, which is du over 2. So e raised to u, the integral of e raised to u, du over 2. Using logarithmic integral of logarithmic function, so we can say that e raised to something is just the same, which is equals to e raised to u over 2 plus c. E raised to u is just the same with e raised to x. The integral of e raised to u and integral of e raised to x, they are just the same. Same format, but not the same value. Same raw format. Okay, so are we done? We're not done yet. So the value of our u is 2x. So we substitute e raised to 2x all over 2 plus c. And this is the integral using U-substitution. For the last example, we are going to have trigonometric function. So for example, we are going to find the integral of sine 3x. Sine 3x dx. So our u most probably will be the variable and the constant inside. Since trigonometric, the integral of trigonometric functions, we have the integral of sine, you have the integral of cos. So which is the destructive destructor of this function, the destructor is 3x. So we use 3x, or we substitute 3x as our u. So u is equals to 3x. Derivative of u will be 3 dx. So the value of our dx will be du over 3. Substitute in our equation, integral of sine u dx. So we have the value of our dx, which is sine u du over 3. So sine u, what is the integral of sine? Okay, comment your answers below. What is the integral of sine? The integral of sine is negative cos. So we have negative cos u over 3 plus c. We have the value of u, which is 3x, so we substitute. So our answer is negative cos 3x over 3 plus c. And that is how you solve functions using U-substitution. Okay, so before I end the class, let's have a bit challenging example, which is finding the integral of two terms. So we have 2x, quantity 2x plus 5, multiplied by x squared plus 5x plus 3 raised to 4 dx. So by just looking at our functions, we can say 2x plus 5 can be integrated, we'll have the integral. We can have the integral for 2x plus 5. But for x squared plus 5x plus 3 raised to 4, we cannot have the integral. So we can say that this function will be our u. So u is equals to x squared plus 5x plus 3. Find the derivative. So that is du equals 2x plus 5 dx. Find dx. So dx will be du over 2x plus 5. So we substitute our original equation. So that is 2x plus 5 u raised to 4 dx. So we have the value of our dx, which is d over 2x plus 5. So u raised to 4 du over 2x plus 5. Cancel. So the remaining variable is the integral of u raised to 4 du. So power rule, plus 1 and 4 plus 1. We can say u raised to 5 over 5 plus c. We have the value of our u, which is x squared plus 5x plus 3. So the final answer will be x squared plus 5x plus 3 raised to 5 all over 5 plus c. Okay, so I think that is everything for U-substitution. If you have any questions, clarifications, just do not hesitate to comment down your concerns. And also I'll be posting the link of your quiz. Goodbye and thank you everyone. See you around.